院长 ，Good morning，Professor 林淼，yeah，
Good morning, good morning.
Yeah.
Hi.
Good morning.
Hey, good morning.
Because I'm at home, so I don't need to wear the face mask.
Yeah.
院长，你一个人口罩先拿一下，你一个人而已嘛。借我一下。你还在主管研讨会哦。
你说我的背景是？
对呀。你跑通告跑错摄影棚了。
Okay, let me change the background.
Yeah.
Okay.
志杰哥，谢谢。
不会。
我们正在讨论时间序啊，因为 A 组的报告比较特别。我们 B 组是轮流 ，A 组不是。不知道志杰哥，您现在对于主持的时间序或是委员没有问题哦？那请问，现在我们在讨论就是，如果说每一个同学都让3位委员给 comment 的话，它有2种方法。第一种，同学全部讲完才 comment； 第二种，讲一个就 comment 一个，你觉得哪一种？
因为我这里刚才得到的消息是说 A 组会分成2个小 A 组在进行啊，所以我个人是认为说，我比较建议是 A 组整个报告完，老师做 comment 这样子。
Okay.
那当然老师也可以问的比较细啦。如果老师那如果一个来的话，那变成每一个都在，可能会有 delay， 每一个都会 delay， 那这个时间会很难掌握这样子。
我来分享桌布一下，所以我分享一下哈。看到哈，this is the school form and 邓老师，我直接讲中文哦，您再翻给邓志忠老师哦。就是请两位委员，因为今天是个人分数比较重要，那相信昨天的书面已经有稍微初步的进度跟完成哦。那今天的话就是满分是50分。这边会给分数，那请注意顺序不要错，因为我等一下也才会真的见识到底是同学怎么上来的哈。那请见谅一下，他们会分享桌布，所以可能会花掉一些时间。那麻烦计分的同学是哪一位？计分同学在吗？请从他正式开始的时候再开始计时。那麻烦志杰哥，也跟同学讲一下，他可以开始的时候，请他讲一下我要开始了哈。所以分享电脑桌布的那个时间先不要进来计算，否则他3分钟一下子就没了。那就是今天的2位评审，中原的2位评审，我会在中午时间跟您用餐时间跟您收这2张哈。那这一份分数。那邓志忠老师的话这个部分如果方便的话，在会后好，邓老师要记得帮我讲哈，请他就是稍微做点记录也没关系。好，因为那个有评审费的问题啊，就麻烦你，邓老师有听到哈，他给一点 comment 就一点点都好，那他不用做这个部分的评分，这个部分不用哈。那就是我今天中午时段，请同学们离开教室的时候，请老师们先不要离开，我们来做最后的分数的一个讨论哈。OK， 那邓老师麻烦你哈。
You do not need to give this numerical score for those 250% part. All you need to do just the column for comment. Okay, just give a few words. That's good enough. So the right corner, yeah, that one, the red one, yeah, that part, okay. Then the rest, forget about the rest, okay. So it will be easy for you. Just a few words or comments will be good enough, okay.
Yeah, yes, sir.
You can write or typing, okay, that's okay. Oh, Professor Shaw, good morning.
Hey, yes. 我上来了。
Yeah, welcome.
Oh, sure. Thank you.
我们就从2005年开始
closing my
，something like 无所谓了，15年。
Good morning, Professor Xiong. Okay, we will start the presentation after 4 minutes. So I need to know everyone is here. TA 可以点名一下吗？大家到了吗？还有2个啊？怎么了？志杰哥，我这一段会稍微就整个交给你了，好不好？哈，因为包括如果我说 OK 全到的时候，我们其实就开始。那目前有2个不知道去哪里了，等我一下哈。嗨，熊老师，静茹，很荣幸哈。那请问钟才王老师会上来吗 ？Anyone can tell me Professor 钟才王？
应该是不会。
没有办法，好 ，OK。那志杰哥今天的那个因为我是全程录影的哈，那就麻烦现在与会的来宾的话呢，就照您原来的 tempo， 一定会先介绍。那只是说我们的 PowerPoint 里面就是只剩下3位委员嘛，哈，另外的参与的来宾就请您口头介绍。那这段时间就麻烦同学们麦克风要开起来，就稍微鼓掌一下了哈，好，这一段哈，再麻烦，好 ，OK， 3 minutes， so we still have one student is not coming, but we are contact him now. 熊老师说点什么吧。
OK，
嗨，
好久不见了啊！
好久不见了。今天的委员是OK， 邓老师你介绍好了啦。今天的委员来，邓志东老师你来哈。老师你的声音不见，邓志东老师你的声音不见了哈。
Okay, yeah, we have 3 judges today. 2 from CYCU, 1 from Vietnam, Ho Chi Minh City University of Technological Education. Okay, the Professor Deng Chengzhong. Okay, we'll call him Zhong. Okay, yeah, he's currently the department head for the thermal engineering. Okay,
a student.
Okay,
Yeah.
Professor Xiang is a faculty at Industrial and Systems Engineering. He's also the director for the Globalization Enhancement Office at College of EE and the CS. Yeah, he has done many things in the international related work. Okay. Yeah, I'm currently the retired professor in mechanical engineering, also the senior consultant for the Office of International and Cross-Strait Education. Okay, and okay, that's it. And we welcome our former president, Shen Ganxiong. Yeah, he was the president at which this program was initiated. That was in the year 2006. This year is the 15th anniversary for this program. And we are very lucky to have all these programs be held online. Yeah, because due to this pandemic, it's very difficult to have this program on site. So anyway, we have 2 groups of the students participate, 20 in total. So one is working for the biomass, yeah, in the College of Engineering. The other one is about the nutrient solution quality monitoring and regulation system in hydroponic environment, which is in the College of EE and the CS. So there are 2 big programs, and each program will have 10 students. And we have 3 students from 3 countries. One is Taiwan, one is the Philippines. We have 2 students from Philippines, 8 students from the Vietnam, 10 students from Taiwan. So that's a brief introduction to this program. President Xiong, would you like to say a few words? That was under your leadership. then we got this program started. It was in 2006. Yeah.
Okay. Sorry. If you come here, please open your camera. Okay, everyone, students. And we have some guests coming. Professor 中文耀 I think some guest is coming now. 那个长语资讯的也有进来哈，欢迎你哈。我们请那个志杰哥帮忙宣导一下，请大家把 camera 开起来。那如果麦克风方便的话，也先开没有关系哈。那等一下我们怎样？嘿，哦，好来，大图库哈 ，OK。中才王老师 ，Professor 中才王 ，Yeah， welcome。We have a video will show to everyone. You are the superstar inside. 你在影片里是超级巨星，你可能还没看过。那个志杰哥请专家做的影片，我们会在最后然后当压轴。我们今天的活动的最后会播放一下那个很棒的影片哦。我们做了一个台湾跟 CYCU 的2分钟的短片哈，很不错的哈。我看一下哈。OK， TA 我们到齐了吗？到齐哦，志杰哥，我们到齐了哈。那刚才邓老师，sorry， 我先讲中文哦。邓老师已经有先稍微介绍一下熊老师，那但是因为典礼现在可能才要正式开始啊，那我们还是会请志杰哥顺着流程，还是把 guest 给介绍过去，好不好哈？我们从正式的开始。钟老师是不是有一些来宾您要先讲一下？是有嘛？对不对？有一位 Iwin 吗？钟老师在吗 ？Professor 钟文耀老师，呀，
有2位。
Yeah, can you tell me some guest is with us? Yeah.
I invite 2 guests. One from the K&H company. They running a lot educational electronic instruments and also have their own vertical farming environment. So that's during the past 3 weeks, we do the one field trip to their company. So the engineer in charge of this activity will also invite him to attend the final presentation. Another one, that's the Kimberly. Kimberly was our first batch of DIGS program. She got the PhD and master program from electronics engineering and now work for some international patent house in Taipei. So also welcome her to attend this conference. Yeah. All right, that's it.
Thank you. Welcome. 我们来拍个手好不好？Welcome. We have a Kevin. OK. Welcome. Yeah. 熊胜干老师，你的镜头要记得调整，好不好？我一直看到你的牙齿而已。熊老师，
我有吗？
后退。Yeah, you need it.
稍微后退一点点。
后退一点点。
OK， 那志杰哥，我们从现在开始正式开始。那请大家，你先宣布，在我们还没有说要关麦克风之前，先不要关。好，你的 camera 跟麦克风先不要关。好，那有适当的时候就请大家同学还是就是拍个手一下哈。OK， 那我们就请志杰哥您正式开始哈，谢谢。
Hello, good morning, everyone. Please turn on your camera and microphone, and we are going to start today's final presentation ceremony. Okay. Ladies and gentlemen, today at this moment, 2021 International Industrial Academic Leadership and Engineering Project IIALE final presentation is right here. Welcoming your participation. I'm Roger Zhang, your MC. I'm so glad to be here again to this meeting. Now I would like to introduce.
Sorry, 你要不要开分享桌布？
没有关系哈。I would like to introduce the professors and guests for today's presentations. The first guest is Vice President Taiwan Zhong. Vice President, are you here?
Here. I'm here.
Okay. Please say something to us, okay?
Oh, I don't expect that I need to say something here. But by the way, I think in the 3-week program, we have experiences the CYCU supporting system for students conducting research. I believe the program will inspire every participant to have a deeper and better understanding of theory and practice in doing research. I think. Hope you and your family stay well and health, especially in this pandemic period, I think. Thank you very much. Thank you.
Thank you, Vice President. And the next one, I would like to introduce our former president of CYCU, Professor Shen Ganxiong. Would I have the privilege to introduce former President Xiong from Professor Deng Zhidong?
Yeah, Sean has been very supportive for this program. At that time, we had a limited project, so he was very generous to supply the fund from the university. Also, we got some funding from the Ministry of Education. That's how we get the thing started. So we were able to invite our guests from the United States coming to Taiwan, and we had to pay for their traveling expenses, also the expenses here in Taiwan. So we are very, very lucky to have our former president Xiong giving us full support for this. We want to thank him for his support. Yeah.
Okay, thank you. And now, President Xiong, would you like to say something to us?
Yep. Long time no see, huh? So,
long time no see.
Welcome everyone. Yeah. Okay. I forgot it started from 2006. Yeah, it's already 15 years. 15 years conference. Yeah, it's quite good. Yeah, hopefully we'll continue maybe 20, 30 years. Then we'll come. It's an important conference. Thank you.
Thank you.
Thank you.
Thank you. And the next one, I would like to introduce the first judge for today's presentation. That's Emeritus Professor Deng Zhidong from Department of Mechanical Engineering, CYCU. Professor Deng, please move your hands to the participants.
Roger, could you share the desktop and the PowerPoint?
Do I need to say anything?
Yes.
Well, I'm very glad. Even during this pandemic time, we still was able to come up with 2 groups, and each group was still 10 students, and to work on the project online. Okay, so it's very good. Yeah, then I was aware of Professor John taking some of his students to have some on-site visits to some of the high-tech companies. So that's an additional bonus for those who are participating in Group B. So yeah, it's a group effort, both from the professors and also from the participants from 3 countries to make this successful. And today we are glad we have 2 formal presentations by those participants in this program. Yeah, I'm hoping that next year we'll be able to do this on site. Okay, the pandemic will be fully under control here in Taiwan. So then students from many countries besides the Philippines and the Vietnam, they can come. Yeah, maybe some of those from the United States, some of those from Japan, even some of those from mainland China. So there will be much broader participation from many countries all over the world. Thank you.
Thank you, Professor Deng. The second, Professor Xiang Weizhong from Department of Industrial and Systems Engineering, CYCU. Professor Xiang, please.
Okay, I'll just say something very brief. Good morning, everyone. I hope so many old friends, like former
President of CYCU, Professor Sean. I think I didn't see Professor Sean for a long time. I'm so glad to see you, and I believe all the students are ready, and I think this presentation will be very successful. Thank you.
Thank you, Professor Xiang. The third, Professor Deng Chen-zhong from Department of Thermal Engineering, SCMC, University of Technology and Education, Vietnam. Professor Deng, please.
Good morning, all professor, organizer, and all students. I'm very happy to be here to participate the final presentation. On behalf of G20 in Ho Chi Minh City, I would like to say you the deep thankfulness to give us some opportunity for our students attend the important program here. Very interesting. Thank you so much. Thank you.
Thank you, Professor Deng. And the next guest is Professor Zhong Wenyao from Department of Electronic Engineering, CYCU.
Okay. Good enough.
Professor Zhong, please.
Oh, you want me to say something?
Yeah, say something.
Okay. I think that's very good opportunity. Even we only have chance to come from different country and meet online, but it still have the very good opportunity to let all partner, our students can be work together and have very good performance. So I hope their presentation will have very good achievements. Thank you. Okay.
Okay, thank you, Professor Zhong. Now I would like to explain the rules of presentation.
Sorry, Professor Miao Shaogang. Sorry, my boss.
The last one, I would like to introduce the host of today's this year's 2021 IILE is Dean Miao from College of Electrical Engineering and Computer Science. Professor Miao, please.
Hi, I think I was almost forgotten. Okay, hi everybody. Nice to meet you again. I know you're going to have a project presentation next, so I'm not going to give any long talk. Okay, I heard that you all have done a great job, so I believe that all of you have learned something that's very useful, and this 3 weeks course is definitely worthwhile. I would like to thank all the people who involved in this course, including all the students, professors, and the supporting staffs. I think my special thanks goes to Julius because she put a lot of effort in it. And as always, it turned out to be an exciting, wonderful, and successful course. So wish you good luck on your project presentation. Okay, thank you.
Thank you, Dean Miao.
Thank you.
Thank you.
I almost losing my job. Okay. 终于我老板有讲到话。Okay.
Now I would like to explain the rules of today's presentation. Members in Group A are separated into 2 small groups with 40 minutes to run presentations in all, which is 20 minutes in small group. For small group in A, at the end of 17 minutes, you will hear one sound bell ring to remind you that you have 3 minutes left. At the end of 20 minutes, the time is up. You will hear 2 sounds of bell rings. Then the next small group A continues. Then the professor will ask questions to your presentation when Group A finishes presentation. In Group B, each member present your topic in 3 minutes. As soon as you start presentation, 3 minutes are counted down. At the end of 2.5 minutes, you will hear one sound, bell ring, to remind that you have 30 minutes left. At the end of 3 minutes, the time is also up, and you will hear 2 sounds of bell rings. Please stop your presentation. The professors will ask questions to your presentation when all the presenters stops. Now I cordially announce it's the time to begin 2021 IILE final presentation. Let's welcome Group A to present their project. And please tell everyone your name and do your self-introduction and present your topic. Thank you. Group A.
Group A, if you are going to presentation, you can prepare the PowerPoint and say I will start now, and we will counting the time. OK， 说一个我要开始，然后就谢谢。
Good morning, everyone. Thank you all for being here. And I'm Jackie. Today, our topic is investigation of the biomass power plants and evaluation of the biomass feedstocks for manufacturing RDF in Vietnam. And our members, we have A1, A2, and A7, and A8. Well, introduction will be divided into 4 parts, and the first one is what is RDF. The next is its classification, then is the manufacturing process, and the next one is pros and cons. So what is RDF? RDF stands for reduced derived fuel. RDF is a fuel source produced from combustible components that the industry calls municipal solid waste. This waste, which includes plastics and biodegradable materials, is usually taken from industrial or commercial sites. RDF has been processed according to guidelines and regulatory specifications, mainly to achieve a high calorific value. This fuel is then used as an alternative to fossil fuels in power plants, like producing electricity. In short, RDF is a renewable energy source that ensures waste is not thrown into a landfill and instead put to good use. That's because the waste is not only a problem to get rid of, but a source of valuable raw materials and competitive alternative to fossil fuels. The next part is RDF classification. RDF is a technology that converts waste into a fuel with uniform properties using physical or thermochemical methods. According to different process procedures, RDF can be divided into 7 categories, namely RDF1 to RDF7. In general, setting waste into an incinerator for incineration and heat recovery is an application of RDF1. And in RDF2, before cross-crushing is processed into waste with a certain particle size range. Okay, and next is RDF3, the MSW process to a particle size such that 95% by waste passes through a 15 millimeter square mesh screen, and from which most metals, gas, and other organics has been removed. And the RDF4, the MSW process to a powder form, 95% by waste of which passes through 10 mesh screen. The difference between RDF3 and RDF4 is that RDF3 is in a particle size, but the other one, RDF4, is in a powder form. And it's RDF5. MSW has been processed and densified into the form of pellets, slugs, cubettes, or briquettes. With the increase of physical procedures such as sorting, crushing, and drying, the non-combustible or unburnable substances in waste are gradually reduced. Their properties are gradually homologous and finally suppressed into solid field rust. And the RDFC, through a heating cracking technology of anaerobic medium temperature, waste is converted into oil. We will call it RDF6. And the last one is RDF7, the conversion of waste into synthetic gases like hydrogen, carbon monoxide, and methane through the gasification technology, with partial oxidation at high temperature is called RDF7.
Hi, I'm Audrey, and I want to introduce the benefit evaluation.
Sorry, it's my fault. I'm Julia. Sorry. Because I forgot an important mission. I forgot group photo. Sorry, because our guests maybe they cannot stay at this time. So I need a group photo now. Sorry, Roger. Sorry. So I needed to take a photo, and you can go on. Okay. Show up, everyone. Sorry, my fault. Sorry. Yeah. 院长处理一下哈。Please turn on your camera. Sorry. I sorry 100次. Sorry 100 times. Okay. Yeah. Professor Xiang and Professor Dong, can you more close the camera? Thank you. It's a very, very important moment. Okay. We finished that, so we need the photo. Thank you. Yeah. 公共中心要sorry Population Center, they need the photo. Okay. Are you ready? Wait a minute. Yeah. Welcome my guest. Okay. Our guest. Let me check. Okay. Oh, my boss. Wait, my boss. 冰妙. Okay. Sorry. 好了吗？在哪里？
I'm already in.
Where are you? Oh, I see you. Okay. Let me. 工作人员可以吗 ？OK 吗？我会切换模式哈。First one. This is our 15 file. You know. Put on your shoulder. Yeah. Again. Okay. 你会截嘛？哈，你截哦哈。1, 2, 3. Smile. OK. 有截吗？你要讲 OK， 不然我不要截。OK. And another one. Yeah. OK. Victory. OK. Yeah. 好了，要讲啊，宅男哦，有好讲了。OK. Next one. Let me try this. OK. And 邓老师很远，向老师有办法吗？再前进一点。You are too small. Okay. Professor Xiang, you can you more close more? Okay. That's okay. And okay. Say cheers. 好 ，OK. 1, 2, 3. Cheers. 截图要讲好，有吗？要讲出来，不然我不知道有没有。OK. Next one. Okay. Your finger 2. Okay. More cute. Okay. Funny. Just for funny. Yeah. Okay. But you cannot this side. You know. You need yeah. This side. You cannot here. Okay. 哦那你要你 OK. 1, 2, 3. Okay, we say bye bye. Okay, just for photo. Okay, bye bye. Bye bye. Okay, thank you. I'm sorry. Okay, thank you. Please go on. Okay, thank you.
So I'm Audrey. I want to introduce the benefit evaluation of RDF5. So in environment, it is poor energy recovery and it has a great impact on the greenhouse gas in incineration system. Also, the dioxin pollution is a serious problem. But in RDF5 system, its great energy recovery efficiency. It can replace part of the energy consumption of fossil fuels. Also, the carbon dioxide reducing effect. This can effectively release the greenhouse effect. And in secondary pollution, the dioxin pollution be the main pollution in incineration system. But in RDF5 system, it has less secondary pollution emissions and decrease the emissions of dioxin pollutions. So in energy use, it must achieve a certain scale to have the economic benefits of power generation. Also, in combustion, it's not easy to control, and the power generation efficiency is about like 10%. In RDF5 system, the manufacturing scale of RDF5 is flexible. We can manufacture in the waste producing area and using in a conservative manner. It is stable and easy to control in combustions, and the power generation efficiency can reach about like 35%. So in pollution prevention, it is release dioxin easily and other pollutions. Also, we need to install the dust removal, acid removal system, dioxin prevention, and control equipment. But in RDF5 system, burning waste meets the dioxin conservation required by laws and regulation. This can use investment in pollution equipment. In ash treatment, the combustion is related incomplete in incineration system. There are many unburned materials, the burning loss is high, and the ash are not easy to deal with. But in RDF5 system, the combustion is complete and the less unburned materials low burning loss. Also, ash are easy to reuse. And I want to talk about the detailed process of RDF5. So at the beginning of the process, garbage is shredding for the first time, and then we can use magnetic separation to separate large pieces of metal. The pieces pass into a green roller where it reduces the moisture by drying. At the first stage in the process, the piece we know for a second time to separate the flammable and non-flammable. Next, the flammable pieces are stacked in magnetic to ensure reuse. The remaining flammable pieces shattering second time to smaller pieces. Then we add stack lime adds to the pieces. The function is avoid garbage decay and inhibit the production of toxic gas such as sulfur and chlorine. Finally, put the piece into the machine to be compressed into RDF5 pills. So there are some advantages and disadvantages in RDF. So about like advantage, for example, uniform in shape and size, so it is easy to store and transport, and the homogeneous RDF is combustions. Also, the low water contents and high heating value let more efficient power generation. It is a method of a low carbon dioxide emissions and energy recovery efficiency of the power generation. But the disadvantage is that RDF is actually with a pricing cost barrier to recovering the fuel fraction, and the yield of energy may be lower than that of the parent municipal solid waste. And it is the next person's turn.
Oh. Hello, my name is Phong, and thank you both for your presentation. Here I would like to introduce about state of RDF in Vietnam. The introduction. The first, the next way, okay. The waste generation in urban area in Vietnam is increasing parallel with the rapid increasing of citizens, the economic growth, and the environment of living standard. Between 1997 and 1999, the waste generation increased by 30%, in which municipal solid waste (MSW) accounted for 3/4. Around 50% of the world solid waste was produced in urban area, although only 25.8% of the country's population was living there. The next. Landfill is a dominant form of solid waste disposal in Vietnam currently. The open dumps which do not satisfy the basic requirement and landfill and located next to residential area. They fully operate them cause a multitude problem for environment and surrounding residents, such as ground surface water pollution by leachate, bad odor, etc. In rural areas where it's hardly access to environmental services, self-disposal is common. Finally, the next way. Okay. In countryside area where it's hardly access to environmental services, self-disposal is common. The waste is often dumped in river or lake, or at the site nearby their home. And next, I would like to invite Thương to present the next part. Thank you.
Thank you for asking. Hi everyone, my name is Thương. I'm gonna talk about the strengthening of RDF in Vietnam. So also the domestic waste in Vietnam is organic matter. So that's the domestic waste is the main source of raw material for the production of environmentally friendly microbial fertilizer and serving agriculture production. And waste is also recycled into the raw material for industry, even raw as material to produce electricity for human life. Next page, please. Recently, it is reported that Vietnam has completed the first waste to electricity plant in Vietnam with the capacities of 1,000 tons a day. So this is the method to gradually replace the form of waste treatment by burying, which takes up a lot of space. And some countries in the world have a great success in the utilizing waste as the renewable resources. The industrial modern closed the process was from using orientation, collecting, sorting, recycling, and producing environmentally friendly products. And regarding about recycling technology, we currently have 3 main recycling technology. The best technology as advanced countries are doing is collecting, cleaning, sorting by the types of plastic and converting it into the basic active ingredient. The second recycling technology is cleaning, chopping into the small pieces of plastics and primary plastic, and then put it into the extruder to extrude all the products. The third technology is turning plastic waste into the parts of construction material, including concrete. And in addition, there is some weakness of RDF in Vietnam. The first one is Vietnam is only recycle and use nearly 10% of the college waste. In Vietnam, waste have been used for a long time, mainly by landfilling or manual burning, and which costs a lot of money each year. Therefore, many landfill has been causing a very, very heavily environmental pollution. So at the same time, wasting a large amount of recyclable waste due to the people habits of not sorting garbage. And so after discussing, we got a little bit of solution. So to improve the efficiencies and develop the plastic recycling in Vietnam, it is very necessary to psychologically implement many legal and economic solutions at the same time, raise public awareness. And Vietnam recycling industry currently have the great potential. The demand of scrap material increased every year by 50 to 20%. Although there is a loss of potential, Vietnam plastic recycling industry have not yet met the demand. And the current status of consumption and recycling, and according to the report by United Nations, every minute 1,000 plastics waste are consumed. So every year people produce enough plastic waste to surround the earth for a time. So this shows that the potentials of develop the recycled plastic industry is great. And at the same time, plastic waste recycling in business also bring many benefits, such as saving energy for primary plastic production, having to save resources that cannot be achieved, and the renewable is petroleum. So the whole series of environmental problems. And one of the effective solutions is to turn the plastic waste into the raw material for industrial plants. And non-recyclable plastic can be used as the input material for factory by co-processing. From the factory will reduce coal consumption by recovering energies from burning non-recyclable plastic waste, and energy efficiency which be much higher than conventional waste to energy plants. And in conclusion, the issues of waste disposal method have been hit in society now. So the amount of domestic waste generated in Vietnam is about 7 million tons a year. So this is the common of use recycling trash for energy. Therefore, the companies in Vietnam do not already reduce the technology look like RDF. However, the distress could be the material of RDF, and when the policy waste of the treatment is improved. And in summary, the RDF is an excellent choice that the garbage disposal method that could improve the problem of the huge amounts of tons of waste. So this is a new and green power generated method in Vietnam. So that is all I have to say. Thank you guys for your listening. If you have any questions, turn on your microphone and we can answer after the discussion. Thank you.
So next, the next group in group A.
Sorry, Monica M. You can turn off your camera. That's all okay. Monica M, are you here? You can turn off your camera. That's okay. Thank you. You show up. Okay, that's okay.
Can you see my screen?
Yes, we can.
Okay. Okay, can start now. Okay, hello everyone. The topic we want to share today is investigation of the biomass power plant and evaluation of the biomass feedstock for manufacturing of RDF in the Philippines. And these are the members of our team. RDF is the fuel produced from various types of waste like municipal, industrial, and agricultural waste. The common application of RDF is RDF facility in the supplementary energy source as a replacement for coal like in cement manufacturing plants. RDF ensures that waste put into good use for reducing the overall solid waste. And Philippines is one of the top exporters of agricultural products in the world. And with this comes a long tons of agricultural waste that is improperly disposed or underutilized. And 29% of the country's energy matrix comes from the biomass. However, these wastes are simply incinerated without first being processed. And next, these two pictures show that the management of NSW and agricultural waste. And in Philippines, the processing method of NSW is as follows: co-processing. Since incineration is banned by legislation in the Philippines, co-processing becomes an alternative method for waste to energy. The plant transfers selected waste into fuel pellets as alternative fuel for cement kiln. 25% to 35% of processed waste is converted to RDF. And anaerobic digestion. Anaerobic digestion can lead to more efficient energy recovery by producing biogas. And landfill with landfill gas recovery. And LFG now operating as LFC is XT6 and another 51 under construction. And next is the treatment method of agricultural waste, direct combustion. This makes use of agricultural residue for the generation of electrical and heat energy. And biomass carbonization. Biomass is densified via two main processes. Yes, mechanical and pyrolysis. Mechanical densification involves applying pressure to mechanically densify the material. Pyrolysis involves heating the biomass in the absence of oxygen. Gasification. This is the process biomass fuel goes through to obtain fuel gas, which can either be burned in a boiler or used for generating mechanical power using a diesel engine. Biogas. Biogas is an energy-rich gas produced by anaerobic decomposition or thermochemical conversion of biomass. The methane in the biogas can be burned to heat water and building, and as fuel in diesel engine generator to generate electricity. And then, in the Philippines, a comparison of NSW and agricultural waste. The left and right picture is the ratio of agricultural waste and NSW, respectively. You can find from these two graphs that the proportion of agricultural waste that can be used for RDF is actually not very high, only 6%. From a proportion point of view, NSW may have more potential, but if you compare the total production produced in a year, you will find that this is incorrect. On the contrary, the agricultural waste that can be used for RDF is nearly 30 million tons, is 2 times of municipal waste. It can be seen that in Philippines, the potential of agricultural waste for RDF is considerable. And then my partner will introduce the material of agricultural waste.
So you can see there are 4 materials usually disposed as agricultural waste. And the first is coconut husk. In the Philippines, the main agricultural exporting products are coconut water and flesh. But shell and husk are seldom used, and they are simply disposed as waste. And second is banana leaves. Philippines is one of the top 5 exporters of banana in the world, with some 2.85 million metric tons exported back in 2018. However, most edible bananas are grown mainly for food. If agricultural waste is not properly treated, many valuable undeveloped commodities will be lost and cause serious ecological damage. Next page, please. And the third is rice husk. In the Philippines, produce an average 2 million metric tons of husk annually. 1 kilogram of rice husk has about 3,000 kcal of thermal energy remaining, which can provide a sufficient amount of clean gas fuel after gasification. And the last is sugarcane bagasse. In 2019, the production volume of sugarcane in the Philippines was around 20.7 million metric tons. Part of it is used as fuel and feed, and the remaining bagasse is left to rot around the sugar factory. Next page, please. And equipment. And you can see the green one, up left corner. It is used in pressurizing and extrude a wide range of input material. And you also can see the blue one. This is polyester. The polyester separates out of pressurized material stream in a rolling fraction. And also,
Polyester requires only a little space, will cause a slight air movement. And with air movement, a large dust removal equipment is also not needed, thereby reducing operating and energy costs. And last, you can see the purple one. It is razor. It is used in fine shredding. After sorting equipment has removed PVC and possible recyclables, razor will fine shred the flat fraction. Next page, please. And next, I will introduce some manufacturing process for RDF. The first step is persuading. It makes the improved material have a consistent particle size and prevent too long time, which may cause more problems. And next is magnetic separation. It is a method of waste management where magnets are used to separate metal from waste because the materials are collected together and separate before processing. And after drying is air separation. In this step, fans are used to create a current of air move upwards, so light material are blown upward and a dense material form. And next is fine shredding. The razor fine shreds the material to furnace ready fuel. And after this process, we will get RDF. Thanks. This is my part.
And hello everyone, my name is Chris, and I'm talking about the theoretical consideration, and it will include 3 parts. And the first part is the calorific value. This value quantity and different the capability of different raw materials to be used for fuels. And this value also referred to as heating value. It's the amount of calorie generated when a unit amount of substance is completely oxidized, and is determined using the bomb calorimeter. The caloric value determines theoretical amount of energy that could be converted into electricity from the fuel. There are including 2 types of heating value, which are low heating value and high heating value. And next page. And the next is the proximate analysis. It serves as a simple meaning of determining the behavior of biomass fuel when it is heating. And in proximate analysis, it is typically assumed that the fuel was composed of 2 types of carbon, the volatile and fixed carbon, and another is ash content and moisture. And moisture is the amount of water more exceeding along with the fuel excluding the moisture byproducts of combustion. And the volatile matters are the components that reality burn in the presence of oxygen. Ash content is the percentage of inorganic materials that are left when water and organic matter has been removed through heating in the presence of oxidized agents. And finally, the fixed carbon was calculated by subtract the sum of percentage of volatile matters and ash content on dry basis from a total of 100%. And next page. Finally, I'm talking about automated analysis. And this chemical analysis is very important to calculate the material balance occurrence. And the analysis is also referred to as element analysis, and including the carbon, oxygen, hydrogen, nitrogen, and sulfur. In this analysis, sample was introduced to auto-sampler of the analyzer and combust at 950 Celsius degree, and then the content of the carbon, nitrogen, sulfur, and hydrogen were measured simultaneously. Once the percentage of these 4 components were determined, the amount of oxygen were calculated by subtract the total percentage on the mentioned element from 100%, and all results were prepared on dry basis. And this is my part.
So good morning, everyone. I'm Sharon Avila. And on this slide, we can see the properties of raw materials that were tested using proximate analysis, ultimate analysis, and bomb calorimetry. So the key takeaway from this data is that among the 4 materials, semi-dried banana leaves, and sugarcane bagasse have high calorific value at 19.8 and 19.4 megajoules per kilogram, respectively. This signifies that these two materials have high energy potential for power generation. However, sugarcane beats banana leaves in terms of low nitrogen content and zero sulfur content. Additionally, sugarcane bagasse has the lowest ash content, which means it will produce less residue after combustion. We can also see that coconut husk shows a large nitrogen content, which can result to high emission of NOx or oxides of nitrogen. Next page, please. So on this slide, I will be discussing the reasons why we chose those 4 particular agricultural waste to study as the potential feedstock for the RDF production in the Philippines. So the group did not choose the raw materials randomly. However, the group collected relative data based on the Philippine economy, as well as the agricultural statistics report and history. So first, let's talk a little bit about the economics of the Philippines, especially the export industry. So among the top 5 commodity exports of the country, banana ranks second with a total value of 1.8 billion US dollars, and coming in at third is coconut oil with 1.3 billion dollars. So from this data alone, we can already assume that there might be a huge potential in the waste department of these large agricultural industries. Next page, please. We can see here the data from the Philippine Statistics Authority, the volume of crops planted and harvested during a specific time period. So this data includes both the agricultural products to be exported and those to be consumed within the country. Next page for animation. So we can see that analyzing the rightmost portion of this table, we can see that the 4 highest crop production of the Philippines from the first 6 months of the year 2020 are sugarcane, rice, coconut, and banana. So sugarcanes had over 17 million crops, rice had over 8 million crops, coconut had over 6 million crops, and banana had over 4 million crops. And these values denotes that these industries can produce a large amount of agricultural waste, which can be sustainably used for the production of refuse-derived fuel. Next page, please. So on this slide, we can see the types of resources currently being incinerated in the biomass industry of the Philippines. So this data shows a whopping 5.9 million metric tons of annually generated sugarcane bagasse, which is the highest among all the agricultural waste in the Philippines. We can also see the data that coconut husk has the greatest equivalent power in terms of total power generation with 3,000 megawatts. And this table also supports the previous data regarding how sugarcane bagasse, rice husk, banana leaves, and coconut husk have the greatest amount of crops produced, as well as the greatest amount of waste generated annually. Thank you very much. Next page.
Hello everyone, I'm Tony. Will talk about the conclusions. Next, I will talk about why Philippines is certain to RFD for energy resource. The research have concluded that by on the case study presented, with a study of solid waste management in Metro Manila. In particular, and the Philippines in general, refer divide fuel IFD present a solid waste management option that can definitely reduce the volume of waste in highly urban areas. Where the volume of waste is very high, IFD technology offers enough for managing multiple solid waste at a sustainable level. It can be said that this technology is here to try whether where we like it or not. The government has already allowed it with certain guidelines on emission level of certain taxes sustainable that are harmful to human health. With the advance of technology, several more are waiting to be considered in order to in the country if you only to reduce the solid waste being deposited into the landfills. Next page, please. Next. And the last, I will talk about potential material to be mainly used for IFD in Philippines. You can see two pictures in the left-hand side to talk about technical reduced volume of major crop in the Philippines in 2016, and the right-hand side we talk about the technical power potential in the same time. So I think the sugar cane bagasse is better. It has the second highest calorific value, and it has much lower nitrogen content than the banana leaf. Also, the Philippines sugarcane bagasse beats coconut husk in terms of viability. Also, there is data regarding the amount of electrical generation per material. Coconut husk has the highest potential, but coconut husk has higher nitrogen content, so has it the advantage of the material. If we consider the material using the electrical potential per kilogram, then coconut husk is good. However, if we consider calorific value of the material plus the amount of material available, then it is sugarcane bagasse. Next page, please. Thank you for your attention for our project. If you have any question, please ask we and we will to answer. Thank you for your attention. Thank you for listening.
Okay.
Yeah. All right. My first question is for the local student about from Taiwanese student about the RDF 5. Do you know any application of RDF 5 in Taiwan? I know your topics are about Vietnam and the Philippines. I just wonder, do you have any idea what happened in Taiwan? Do we have RDF 5 or not? The first group, like 周安杰好了。Hello.
Hi, Professor.
Yes.
So I know there's a industry in Hualien, and it is not, but this RDF this technology is not is not used very much like other power generations. So I think Taiwan can so I think the government can keep this technology in the future, and I think it can be the a main power generation in Taiwan in the future to replace like incineration system or like nuclear system or like biomass system.
Okay, thank you. How about for the second group or group A? The same question. How about Jiang Yihao? Would you say something?
I think Android is said is very complicated, but I want to support because in Taiwan, we also use organic sludge. We also have organic sludge, and we also use this organic sludge to produce the RDF file. Yes, just that.
So basically, thinking we are not here in Taiwan. We don't use RDF file that much, right?
Yes, we don't use so much. No, don't like Japan because I think Taiwan in this technique we are very slow to open this technique. So I think after the study really study we can begin to open this technique. Yes.
Okay. How about Wang Junkai? What do you think?
Yes, I also agree Jiang Yihao's his opinion. And beside organic sludge, we have a kind of grass. It's called 狼尾草. In Taiwan, we also use this to manufacture the RDF. Yes. Although Taiwan developed this RDF or biofuel is slow than other country, but I think we exactly have keep going in this direction.
Okay, thank you. Let me ask the student from Philippines. Is there your name, Sherwin?
Yes, Sherwin.
Yeah, Sherwin. In your report, would you say more about in Philippines, do you have RDF5 system or not?
RDF5 specifically, no, but we have other types of RDF, the lower kinds of RDF. Especially lately, what I've known is there is this province called Rizal in the Philippines, and it is operated by GATSI. It's a green company, and what they do is they collect local municipal waste, and they use that to produce all sorts of RDF from RDF2 to RDF4, if I believe. I don't know if they produce RDF5 specifically, but those RDF are used to supplement energy source for their cement kiln and their cement manufacturing industry.
Okay, thank you.
Thank you, Bob.
Thank you. So I want to ask a student from Vietnam. The first group of Group A, they talk about in your presentation. You say you do have some kind of electricity plant in Vietnam, right? Like RDF5. Would you say something more about that?
Actually, we do have the electric. We don't have the electric. No, we don't have the RDF recently because our country have a low level of technology. So we just use the renewable recycling waste to transfer it into the electricity. Not really produce some kind of the block like RDF. Yeah.
Okay, so you say that because in your slide, page 23, right? You say you have first waste to electricity plant, right?
Yeah.
So you don't think that's RDF5 or not?
No, this I think it's not gonna be like RDF5. They just turn the waste to electricity.
Okay, you all right? Okay, maybe just burn and use when the burning generate energy, use that energy to generate electricity, right?
Yeah, just
okay. Oh, okay. So that's different. I see. 邓老师有没有什么要问的？
Yeah, I think the project you are working on is very important for this so-called biomass power plant. You can use two types of things: RDF, refuse derived fuel. The other one is MSW, municipal solid waste. Yeah, obviously from what you present, Taiwan has more advanced technology to do this, but the quantity for Taiwan's agricultural waste is rather low. I think in the Philippines, also in Vietnam, you have much more waste. So as a result, you may want to help the country or the government may want to get more advanced the technology to burn their agricultural waste. Okay. The other one is you are talking about using those kind of methodology, RDF. Yeah, try to break that down into really small particles or even powders. You can result in a more complete combustion. As a result, it probably will reduce the carbon dioxide emission. Also, eliminate the dioxin. So those are very nice to know that. But eventually, we want to go into the phase of so-called zero carbon. So some of those just by combustion may not be as good. So yeah. And the last thing I want to congratulate you is your PowerPoint PPT made is very nice. Yeah, you have a very few descriptive words along with a picture or a cartoon, make the quite vivid. So yeah, that's a very nice point for your presentation. Okay, thank you. Now we go to this. Oh, by the way, one thing for all the students from Taiwan, when you are saying Philippines, it's better put the Philippines. That's their official title, the Philippines. Zhong, Professor Young from Vietnam, you want to comment on those?
Thank you, sir. Thank you your my presentation to student. I have some comment. Your topic is very detailed. When you mentioned about RTF, should get information about statistic data from tree severity from Vietnam, from Philippines and Taiwan. Because I remember in Vietnam we had several power plants already use the RDF, but not so much, only several. On just slide on PPT, when you mention about the three main recycling technology, when you indicate detailed process, I think you should carry out the flow chart. It's easy to understand. Here for the first group of group A and for the second group of group B, I suggest you when you write the conclusion, I think you should not indicate the table data. You should move to the result and discussion. Okay, you only carry out conclude the main result in the conclusion section. Okay, and sometimes I see on your slide on PPT, you only write indicate a photo, a figure, but you don't indicate some information. I think you should indicate the main information, highlight information. It's better. It's okay. Okay, thank you. So that's my comment.
Thank you. Thank you.
Yeah.
Thank you, professors, for your precious comments. And let's move to Group B to present their project by the number. Okay. Group B, Cedric, please. Right now, three professors, is the time for your question.
Hello, hello. Good morning to our distinguished panel, professors, ladies and gentlemen. My name is Christine Joy, or CJ. Please allow me to introduce our group project entitled Design and Realization of Nutrient Solution Quality Monitoring and Regulation System in Hydroponic Environment. This is like a therapeutic activity in your own house. To find out more about our group and our project, please visit our website or you may scan this QR code. Again, we are Group B, and our work was done under the careful supervision of Professor Danny Chung. Our group members come from three countries: the Philippines, Taiwan, and Vietnam. So B1, B2, and B10 are from the Philippines, and B1 and B2 are in charge of the Python programming, testing and system integration, and machine learning. B3, B4, and B5 are our Taiwanese members who did the environment configuration setup and Arduino programming. B6, B7, B8, and B9 are from Vietnam and they did the research. Finally, B10 is from the Philippines, who also did research and website development. So our team was divided into two. B1 to B5 are students who are here in Taiwan, and we were in charge of the hardware. B6 to B10 attended the summer program remotely, so they were in charge of the research and the website. So we will be talking about these points, and allow me to start with the project highlights. This summarizes the contributions we made within the 3-week camp. First is the hardware implementation. This includes the motors, the solutions, etc., and software development involving the Python Arduino programming. And combining these two, we were able to integrate this into one system. And from this system, we gathered data points and data set that we fed into a machine learning model where we aim to predict the value of predict the future value. And all these are found in our project website, which again, you can view by scanning our QR code. So next, please.
Hello, I'm Bidri, and in this slide you can see the milestone shows that the difficulties we have faced in these 3 weeks. There are 3 major challenges in each of the week under below we have faced. In the first week, we have to learn how to organize idea and communicating with others. And the second week, how we try to use the limited vocabulary to buy the things we want is also the problems we have faced. Also, and the next one is the last one. In the 3rd week, how to connect the AD board with the Arduino board effectively is the most difficult problem we have facing now. So next. Yes, in this Gantt chart, we can see that there are 6 main texts on the left of the table, which shows what we are doing in the overall 3 weeks. The website page and the systems experiment are still doing, and we are observing and keep those data uploading to the website there. So the rest of the 4 texts we have already done. So next. This is our system environment are doing. Next. Also the props and the system configuration. Next. So let us keep the V9 to introduce more about what the hydroponic is.
Okay, hello everyone, hello professor. I'm Be Nice. Now I'll be introduction about hydroponic farming. First, hydroponic is a method of growing plants in water without using soil. Advantage of hydroponic farming. First is faster plant growth, bring more yields, no weeding necessary, fewer pests and disease, much more water efficient, more space efficient. Next. This sum is outstanding advantage of hydroponics. First is faster growth. Plants get everything they need all the time, so they don't waste growing a lot of roots or searching for nutrition. The second is no weeds, reduce pests. Gardening without soils can eliminate the weeds, so you don't need weed spray. Next. The third advantage is the great plant quality and taste. Since the plant get everything they need all the time, it will reward you with a great taste, strong and fast grow. That the overall get the plant quality. Next. This is time for harvesting soy and hydroponics. The first week we using soy farming. The height is 149 millimeters. In hydroponics, the height is 148 millimeters. But in the first week, the plant in using soils is 169 millimeters. But in the hydroponics, the height is 185 millimeters. Next. This is water consumption of using soil and hydroponics. Water consumption of soil farming is 70 liters per kilograms, but in hydroponics, this is just 7 liters per kilograms. We can see that the water consumption of hydroponics farming is less than soil farming. Okay, next. These are a table showing the comparison of hydroponic farming and soil farming yield reductions. This example like lectures, if using soils, the harvest yield is just 52 tons per hectare at harvest times. But if you be using hydroponics, the harvest yield increases to 300 to 330 tons per hectare at harvest times. Okay, next. This is the introduction of soil farming. The advantage of soil farming is soil is abundant everywhere. Soil industry is well developed. It's less labor intensive. That makes the startup cost is cheaper than hydroponics. But the advantage of soil farming is slower plant growth, bring more pests and disease, require more water, using a lot of pesticide and fertilizers. Soil is easily damaged. It takes time to recover. Okay, that's it. Next one. Thank you.
Hello everyone, hello Professor. I'm B8. I will present two components of hydroponics. There are 7 main subsets of hydroponics. Some of components below are optional, but each system you evolve these main components. Next. Nutrient-rich solution. The hydroponic nutrient solution is the most important part of entire system. Land get nutrient from this solution instead from the soil like conventional farming. Nutrient solution is pumped, dry or in direct contact with land roots. Nutrient solution can be remined or informed mixing a variety of solution into water to the air solution. Hydroponic nutrient is two form solution and powder form. Nextly, revolver. A revolver is a tank used to store nutrient-rich solution for land. Need to make sure that the revolver does not leak. The revolver must be dark or painted to prevent light can get into the side or bottom of the revolver. Nextly, going dry is where you grow your land. The size of going dry depends on the size and number of plants. Going medium. Most systems involve a going medium that add a choice detail. It will support your land and roots, help assure the solution and keep the land moisturized should the boom fail. Some of best growing media for hydroponics is rock wall, rock, dry hoods. Necklace. Symmetrical pump. This is a nutrient pump. This is how the nutrient solution gets from the revolver to the plant root. Need to lean and maintain the pump regularity because it's clean the water solution. Switch to the pump with appropriate capacity for the system. The air pump. The air pump provides oxygen to the nutrient-rich solution and in some systems to the land root. These pumps are much more necessary if your roots are in the solution 24/7 because they have Ensure your route aren't suffocating. Next, please. Drawing lines are due to be like sunlight. LED draw lines are pencil, but it share electricity and hair long lifespan to fluorescent boost. LED lights can be used to provide a customized spectrum that is ideal for drawing different types of lens. Next, please. Our lamp light weighs 453 nanometers. It's low to blue light and good for lens. And BBFT is 118-24. It's higher than the infrared value, so that's risk value for our letter. Next, please. This is a diagram and estimated cost of components. Thanks for attention. Next one.
Also, in this hydroponic project, in our group, we choose the lettuce to be our growing plant. So let me just introduce some of the background about the lettuce. The lettuce are grown in the colder climate, and as we can see the table below, though there are two many of the different categories of the lettuce having different of the harvest day and the temperature. But we can see that though the different categories, both of them are preferred in the low temperature environment. And about the lettuce nutrient, including the three main elements NPK it had, is the suitable for its pH, EC, and ORP range are also under below. Next. So why we choose the lettuce but not the other plant is because the lettuce is not only rich in its vitamins A, B, C, the most important is that it's not easy to get a pest infestation. Also, some kinds of the lettuce are in very high economic value. For example, the iceberg lettuce is also a good case. As we can see the table below, we can find the Vietnam's price of the lettuce are lower than in Taiwan or Philippines in average. But if we can have our hydroponic system and grow it by ourselves, each of the lettuce we grow will only cost us about $0.11 US in buying each of its seedlings. It's very low cost. So however, opposite of the pros, the lettuce also have the cons in that its root cannot be too dry or too wet environment. Otherwise, it will root easily. So next. And next meeting will help us to understand more about the purpose and objectives of our group. Thanks. Next.
Okay, good day, ladies and gentlemen. I am B10, Trevor Del Socorro from Mapua University, Philippines, and I will represent our group project's problem and objectives. The primary problem we are trying to address is the issue of the parameters moving outside the range of acceptable and optimal values and ensure that the lettuce plant will achieve its highest growth potential given the controlled, monitored, and regulated environment. So to solve this issue, our main objective is to create the hardware and software models that will assess and monitor the specified parameters in the hydroponic environment. So to be specific, there are the pH level, conductivity, oxygenation levels, and temperature. In addition, a regulating system will encompass a significant portion of our model. The technicalities and specifics will be discussed later on in the presentation by my fellow groupmates. So in order to achieve the main objective, we had set various specific objectives that are necessary in the execution of our study. So for our first specific objective, which we did in our first week, the group researched on the concept and structure of a hydroponics environment just to get the feel or familiarity of this topic. Within our group, we presented all of our findings and research. Second specific objective was we defined measurable parameters that impact the lettuce plant growth in the hydroponic environment. We had successfully done that as we had known the parameters that we utilized in monitoring and regulating system. Third specific objective was to determine the optimal values for each parameter. So the findings for this objective will be discussed by the succeeding speaker. So they will focus primarily on the significance of each parameter and the specific optimal values, respectively. Fourth is the main objective, which is to create the hardware software model. And we had also set supplementing objectives in the study. in order to abide by the project title of realizing the discoveries and findings from the model we had created. So we discussed the results and setbacks that we encountered in the study, and we also concluded realizations and recommended improvement of processes, methodologies, and execution. So this is done to disseminate information for future researchers who want to delve into the field of hydroponics and somehow provide them with our own personal insights based on the results we had obtained from the study. The next part will be the significance of each parameter.
Good morning, Professor. Good morning, everyone. I would like to introduce my part, the importance of each parameter. As you can see, there's two pictures, the one is growing in soil and the second is growing in hydroponics. When growing in soil, all the microbiome as well as the soil itself have to make nutrients available to the plant. But when you take out the soil by growing hydroponically, that's all unseen hard work by nature is now controlled by the grower. Next. Because of the lack buffering capacity of the soil, so the solution pH can change during the production. All the elements, the pH, along with the oxygen level, suitable set, RGB, and the temperature need to be closely monitored. Next. Now, let's take a first look at the four most important parameters, the pH, the EC, the RGB, and the temperature. The first, pH. The pH factor of the soil reflects its acidity level, which is important to consider because all the plants require different level for the proper growth, and imbalance can block the plant ability to absorb them. Different nutrients are available at different pH range. In hydroponic, the ideal pH range is between 5.8 to 6.2. This range provides the plant with the maximum accessibility to the most nutrient. Next. A measure of acidity with a scale ranging from 0 to 14, from acidic to alkaline. We can measure the pH by the pH probe, pH testing kit. It's got about $5 each. We can control and measuring the pH by if the water is acidic, we use the pH up. If the water is alkaline, we use the pH down. Next. I want to explain the formula how to measure the pH. So the one divided cation hydrogen. So if the activity of the hydrogen increase, the pH decrease, and the logarithm change part of the equations mean that each time you go up or down by one whole pH point, example from pH 5 to pH 4, the change in acidity is changed by a factor of 10. They explain why precise control down to 0.1 on the pH scale is necessary. Next. The next I want to introduce about the EC. The EC is stand for electrical conductivity. It is a measure of how well a material conducts electricity. The ion with the greatest quantities in high EC solution is typically nitrogen, phosphorus, and potassium. However, if the AC is too high, the leaf will become brittle and brown. Eventually, the leaf will die. If the condition is not correct, the entire plant will die, as you see in the second pictures. Next, we can change the amount of salt dissolved. If the AC is high, we add water to balance the amount of salt. If the AC is low, we use nutrient solution salt. Because AC have related to pH, we should measure the constant pH. Fix the cation and anion in the proper range before testing the ECs. We use to measure the EC, we use conductivity proof. For next to put it in presentations.
Hello. Good morning, Professor. Good morning, everyone. I'm Trần Quang Đức Thịnh, P7, and now I'm continue our presentation. Let's talk about the ORB. ORB is mean oxidation reduction potential. It's an electronic measurement in millivolts of a chemical ability to oxidize or reduce another chemical. Both of oxidation and reduction are chemical processes that involve the transfer of electrons between molecules. It means that gain or loss of an electron. So ORB measures the likelihood of such reaction in your water. I found that one of the biggest use of ORB is water disinfection. For example, you know chlorine is used to treat swimming pool water in case such a disinfection. And ORB also can be determined by the formulation you see on the slide. Okay, next. And the last one is temperature control. The temperature of the nutrient solution has a direct relation to the amount of oxygen consumed by plants. Temperature also affects solubility of fertilizer and uptake capacity of roots, being evident the importance of controlling this variable, especially in extreme weather. I found that the best temperature range for the IPAC lecture between 55 to 75 F degree. The temperature also relative to the result of pH. So when you calculate, make sure the temperature is normal when testing the pH. To control the temperature, we have various solutions, but the most common way is using water chiller for hydroponics. But it's very expensive for us and issue for bigger systems. So our solution is using the air conditioner for control the temperature, and if the water is too cold, we turn on the heating lamp. And if you have two-way air conditioner, you don't need the heating lamp to heat the water. Okay, that's on for my presentation. Next, please.
For the overall of the lectures, the pH, the pH is range from 5 to 5 to 6. The EC range from 0.8 to 1.2, and RGB range is from 244 millivolt to 468 millivolt, and the temperature for the lectures is 18 degrees to 24 degrees. Next.
Cedric. Hello, Cedric.
Hello.
Yeah, you can say something.
Cedric, I cannot hear your voice.
Hello. Can you hear me
Yes,
now?
we can hear you.
Okay.
Speak loudly.
Loudly, okay, please.
I think my earphones is broken. We will discuss the hydroponic system, circuit diagram, and operation. To be able to detect the different parameters such as pH, conductivity, or RP and temperature, we use different probes and sensors. Upon reading the different parameters, it will be fed into the different boards such as the analog devices board. This will read the parameters and send it to the Arduino for signal processing. So aside from the Arduino board, use our computer to implement Python coding so that it will be able to communicate to each other. Upon comparing it to the values in the range, so we will be able to control the pump, the heating lamp, and also the solution that will be fed into the system. Then after a few minutes, it will do the sensing again, and the system will go on until it needs to correct again the parameters. Next.
What happened now?
Hello everyone, my name is David.
Excuse me,
I'm
someone
the
can tell me.
B5. Everyone can hear me?
Tell me what number you are. B5 or B?
Yeah, B5.
What happened to your group? No.
I'm use the Chen Xiangzhong's computer because I'm computer have
Okay,
internet
come back.
problem.
Yeah.
Okay.
The screen is come back. Okay, that's okay.
Okay, and I will introduce about our equipment and materials. And this is whole system we need use to our system. And we need a Arduino Mega to control our pump system because our pump system is used to injection the solution for control the every value like EC or pH, and we need to temperature probe, EC probe, and pH probe, and ORP probe to detect our value. And we use analog device CN0428, ADI CUP 0329, and ADU CM355. These three things compose one thing to read out our plot the sensor value, and we plant lettuce, and we need nutrient solution and water to control the EC value, and we use the acid solution and alkali solution to control the pH value. And next, and before we use the pH Pro and EC Pro or ORP Pro or the temperature sensor. Before we use this sensor, we need to clean sensor and measure the standard solution. If the like pH 4 or pH 10, if the sensor tests the standard solution, the value is not inaccurate. We need to adjust scale to the standard value, and we need to clean the sensor again and measure the standard solution until the value is accurate. And then we can measure our hydroponic solution. Next. And on this side, we have our hardware test configuration and diagram. And we use 4 Pro like BA, Big B, BC, and Big D, like pH Pro, EC Pro, ORP Pro, or temperature sensor. And we connect it to AD Pro to read out the sensor value, and sensor value will communication to Arduino, and Arduino will comparison the value is in the range, and if it out of range, you will control the pump to injection the nutrients or water or acid solution or alkaline solution. Next.
Okay, hello everyone. My name is Chongxiang Zhen, and you can call me Nick. And now I will introduce about how does we test the parameter about pH, EC, and temperature. Let's start from the pH. You can see this configuration. We have to calibrate our sensor first because we need the correct value. Then we measure pH value and check whether the value match the range between 5.5 to 6. If it's less than 5.5, the pump will add alkali solution automatically. And if the value more than 6, the pump will turn on to add acid solution. Both of them work for about 1 second, and then we wait for the solution to spread maybe 1 minute. We have circulation device to help solution spread. This is to allow the solution to be measured more accurately. And we measure the pH value again until it matches the range. If the value is correct, we record parameter and the number of seconds the solution was added. And don't worry, we will fix the adding time to let the solution will not fill up. Next, please. Thanks. Okay, this is EC testing configuration. It's very similar to the pH, but you can see the top. We need to prepare normal ratio solution with nutrient solution and water. Then we go through the same steps as pH testing. The suitable value range of EC is between 0.8 to 1.2. If the value what we measure less than 0.8, the pump will start to add nutrient solution to let EC value more higher. On the contrary, if the value more than 1.2, the pump will stop to add water. If it is correct, we will record parameter and the number of seconds the solution was added. Next, please. Okay, and then this is about the temperature testing. We measure the temperature first. During daytime, if the temperature is higher than 23.89 degrees C or higher than 18.33 degrees C at night, we have to use relay to turn on the refrigeration rod to let the temperature of nutrient solution more lower. If the value of temperature is lower, these two boundary value, we just rest about 5 minutes and then measure the value again to do the cycle. This enables automated temperature monitoring. Okay, thank you. Next.
For the machine learning task, we divided it into 3 steps. First, 2 parameters, conductivity and ORP, are measured every 10 minutes. And then the data is normalized and scaled. And using the data from the past hour, we aim to predict the conductivity value of the next 20 minutes. So our data is made up of 4 columns: time, EC, and ORP, and the index. Since this is time series forecasting, meaning we consider the past values to predict the future, we convert these time column into timestamps. And this is the summary of the model. I used 2 LSTM layers, or long short-term memory, which allows us to save in our memory the past values. Using this block of code, we are able to predict the next values, which are 1.14 and 1.127 millivolts. And these readings are also shown graphically here. The white graph is the actual values and the yellow is the predicted. As we can see in the beginning, it seems that the yellow curve, or the model, is trying to mimic the actual here. And in some parts, we can even see that the curves overlap. However, the fitting is not very good yet, mainly because we only have 44 data points due to the very limited time that we have for the project. But I still believe that this model is capable of generalizing better. And as proof, we measured the root mean squared error, or RMSE, which is one of the most popular KPIs, or key performance indicators, of a forecasting task. So generally, we want the RMSE value to be lower. And more importantly, the value of the RMSE for training and testing should be close to each other, which is what our model was able to get. So for the future, it's very critical to gather a lot of data, especially for any machine learning task and especially forecasting. And there can also explore other models or possibilities, like maybe quantum machine learning and other stuff. So next, please. For the website, Trevor.
Again, good day, everyone. So this is the overview of our website. Again, if you wish to see the site firsthand, you can scan the QR code. Can you guys show yeah, there. You can scan the QR code through your mobile devices. So basically, our site contains the day-to-day progress, the description of our study, the contributions and profile of each member, and I personally provided a general overview of the concept of hydroponics, as not a lot of people is familiar with this concept yet. So the primary purpose of this website is to document our progress and also to impart information to those that are very much interested or at least seeking knowledge on this topic. So again, if you wish to visit the site, you can scan the QR code presented in our PPT. Next slide, please.
Regarding our reflection, you may browse through our PowerPoint to see how we did during the camp and what we feel during the camp. So for the end of the presentation, we have a our day-to-day tasks. We have an example of what are we doing. We're doing the experimentation and building up the project.
It's no voice, right?
Yes.
There's no voice?
Okay.
Next would be the explanation of the system and how it functions.
Can you hear the video?
No, I cannot hear the video.
Oh, you should have told me. Oh, okay. Maybe we can. Let me try. Okay, can I try again? Sorry.
Go.
Hang on. Okay, let me see.
Good morning from the lab.
Can you hear it now?
Yes.
Yeah, yes.
Yes.
Guys, say hi. So what are you doing? What's that?
This is our nutrient solution.
Okay, so that's the nutrient solution that we can put here in our setup. See, I think they grew a little taller. They used to be as small as I look, and now they're as big as them.
Aside from that, we have a video of the actual system. So we explain about the system.
I am Cedric from Group B, and I will introduce our hydroponic system. A hydroponic system is composed of the lettuce and the nutrient solution. So for our project, we aim to regulate and monitor the parameter of the nutrient solution using these different probes to measure the parameters of our system and correct them with the appropriate solution. So as you can see, we have different motors that is connected to different solution that will correct the parameters of the nutrient solution. So to process the parameters, we have our different boards, from analog devices and also from Arduino. So these boards will process the signal and record it via our PC. So our PC records the measurement, and upon doing the measurement, the data will be saved in a CSV format. After that, we will do a machine learning to develop a much better system for our hydroponic system. That's all. Thank you very much. Good day, everyone.
Okay.
For the summary of our system and also for the recommendation. So we recommend that we spend more time in gathering information regarding the probes. We actually encountered a lot of problem regarding the probes, especially the pH probe. It's very unstable, and also given the amount, the constraint in the budget, so we were not able to implement some parts of the program. We were not able to have a heating rod because we're already out of budget. So we were not able to properly control the temperature. And since the boards are very different and very small literature was given to the analog devices board, we find it hard to make them communicate. So we use the PC for the communication task. And regarding the data for the machine learning, so if we are given more time, we would be able to predict a much better plot and prediction of the conductivity, ORP, and the pH. And aside from that, we were not able to dismantle the setup for the hydroponic system, so we're not able to control the ORP, but we were able to monitor it. So for further details of our data, again, we invite you to visit our website. Thank you very much, and that is all.
Okay.
Thank you.
Okay, thank you, Group B. Now it's the time for your questions for Group B. 3 professors, please.
All right. Let me first. I want to ask a little bit technical question. In on your presentation slide about like 35, page 35, and you talk about how to control your parameter, right? Hydroponic system. You have 3 parameters: pH, EC, and temperature, right? I just want to ask, like when you because there are 3 parameters. Do you think all these 3 parameters, when you control that, will they interact with each other or not?
Based from the reaction we get from our measurement, yes, they interact with each other. Example, when pH is added, the conductivity also increases. I think not pH, when acid or base is added, the conductivity also change. But we try to make the control system as simple as possible. So we conduct after measurement. If it's out of range, we will correct it. So there's a possibility of oscillation, but since we allow a lot of time before each measurement, so I think the nutrient solution was able to normalize and we're able to come up with a stable data, even though each parameters interacts with each other.
Yeah, I know because you don't have a lot of time to do this. I just wonder. I just suggest if in the future you want to do this, you may. I think your machine learning model should consider the interaction between all these and come out a better prediction model. I think. Okay.
Yes, perfect.
Yeah. All right.
Yeah.
And one more thing is about, because I think my slide, I have the page number are different to yours, but anyway, let me, because I'm from the industrial engineering department, we consider money. So in your equipment and the material, you estimate the cost is about, on my presentation is page 33. Here is, this one. The total money is 422 US dollar. So Julia gave you all this money, or just kidding? I just wonder, like, it costs a lot of money to do this experiment, right?
Since we are already in the university, some of the materials is already available, and Prof. Chung's laboratory previously have smart farming equipments. So we already have majority of the parts, like the pump, the relay, some of the boards. This is based on, because the lab of Prof. Chung specializes in smart farming. So we include the prices just in case if you want to create your own hydroponic system, you know the approximate price to do it.
Okay, yeah, I know. I just, because if you want to start this experiment, still need some money to do that. Okay, I think Professor John has a very good lab, so you have this kind of support to do this project. I think your experiment is very good, and if you have more time, I think will come out much better results. And one more last thing, because I'm from IE again, I wonder the money, like page 25, you're talking about the price of the lattice, right? My page number is 25. I don't know what is yours about the lattice. Yeah, here. I want to ask a local student from Taiwan. So what do you mean like 300 grand unit US dollar, and it costs about like $2.58. Okay, anybody answer this question? Seems like, and the Philippines is about $2.76. I think so. Philippines is more expensive than Taiwan. I mean, I just wonder the number comes out. It's not a big deal. I just wonder. Okay.
Oh yes, sir. About the data, about the cost I have found in Taiwan, I found the supermarket like the Pirk Smart or the Carrefour, something like that, and I averaged the price. And in Vietnam's price, I have called the Vietnam group partners to find the price in Vietnam. And in Philippines, I just search for their website to understand their maybe
Exchange rate.
six of those status.
Okay, that's okay. It's no big deal. I just wonder. I just wonder the accuracy of this number. I just wonder. It's no big deal. It's no big deal. It's not very related to your project, but I just wonder. Wow, the number are for me a little bit strange. Okay, that's it. Okay.
On the same issue, I was talking to Professor Xiang about the iceberg lettuce. It costs 258 for, like in Taiwan, 300 gram. That must be some kind of like organic food. Usually organic food costs much more. Yeah, it's probably twice as much. Yeah, if you reduce that by divided by 2, then probably it's okay. Yeah, anyway, I think for Group B, you have all these things implemented because you have several people working on the lab and some of the online students, they are working on the research. So that's different from the Group A. Group A, all they can do is just doing the literature survey, so they don't have concrete numerical numbers to talk about. Yeah, so that's your advantage. Yeah. Also, you have these flow charts and milestone time series chart that will give us a very good idea about what's going on. Yeah, so those are good points. So yeah, that's also just like Professor Shen was talking about. Professor Zhong has a very good laboratory, and I noticed he probably have two students and plus maybe one PhD candidate working on that and helping you out, so you can generate much better result. Yeah, again, anyway, so that should be congratulated. Yeah, you have done a marvelous job to get all the data and points. Okay, that's good. Turn the time back to Roger.
Professor Deng. Professor Deng. Deng Shenzhong.
Oh, Deng Shenzhong. Okay, yeah. Okay. Zhong, please.
Your voice. Please turn on your voice. Yeah.
I turn my phone on. Okay. Thank you. Thank you for your presentation. So on slide 38, you mentioned important parameters. You mentioned 4: pH, temperature, EC, and ORP. However, I remember when you grow the vegetable this year, we should mention about the humidity. But in here you only mention about temperature, EC, or pH. And you mentioned on lettuce, you carry out the value for 4 parameter. So in here only for lettuce or other vegetable. So I think you should indicate or reference some data here, some reference. Okay. Do you understand? So in here. I mean, why don't you add another parameter, humidity, in here?
Humidity can be considered, but humidity is very hard to control as compared to the four parameters because you have to control the whole room for controlling humidity. And we're based on our available budget, we already don't have enough money to buy humidity sensor.
Thank you. And how about this value for pH, range of pH for EC, O of P temperature. So here only for liters, lettuce, or other vegetable. How about if we use this data to other vegetable, other plant, and
Yeah. Hello,
how about you?
Professor. These values in this slide are particular for lettuce, but we also searched for the optimum range in hydroponics and example pH. I think we put it here. For example, pH, the optimum range does not here. It's between 5.8 and 6.2, and it varies a little bit when we change the kind of vegetable. So that goes the same for the other parameters also. These are specific for lettuce, but if we change it a little bit, then it can only also be the same value for other vegetables, which we can search and find in some literature that we have in our reference paper.
Okay, thank you. So you already design and fabricate your equipment. So have you compare when you using the solid method and hydroponics method you already use in this project?
Hello.
Come again,
Yeah.
sir. I think it's a little choppy. May we hear the question again?
I mentioned you are when you do experiment, right? You already compare when you use this method, hydroponics, right, with the solids, the traditional method. Because in here you have to pay a lot of money to compare with the solid method, right? Yeah,
Yes,
you need to
I
use
think
the refrigeration rod,
In the
some
yeah, the
detergent.
Vietnam group can answer it.
in the page 14, in the page 14, we have a comparisons between the in the page 14.
Yeah.
Yes, we have a comparison between field using soil and field using hydroponic for various of crop, and especially for the lettuce. Tons per hectare at the harvest time when using soil is 32, but in using hydroponic, there's about 300 to 300 to 330 30 ton per hectare. So we have mentioned this in this chart, the difference between using soil and using hydroponic.
Okay, thank you. So how about this data you get from the paper, scientific paper?
I'm sorry. Can you ask again?
I mean, this data you already indicate in the slide 14. It from your research or you get from the scientific data, the paper, scientific paper?
We use both from related literature and our future predictions about the lectures.
Okay, thank you. So, thank you, everyone. Thank you.
Thank you, Professor, for your questions.
Okay. Thank you, Group A and Group B. Now, finally, we finish all the presentations. Could I have the privilege to ask for the sentiments from our professors? Professor Deng, do you have any comments?
I think both groups has done very good job. Yeah, for Group A, due to the lack of real life implementation, they did a lot of research survey. They come up with some kind of description about what to do with the solid waste and also the refuse generated by agricultural, product. So that's good. For the second Group B, they had elaborate laboratory facility also with this most advanced machine learning, so they can do some kind of evaluation of their result and come up with some concrete number. So that's very nice. I just one thing I wonder is so because the product of those hydroponics is much higher than those yield by using soil, so it should bring the cost down. So, but I did not see the cost. Well, I didn't see the cost for the real life comparison. But those are just some numbers. Yeah. So if you can produce like sometimes maybe 6 times, some of those are very high. Some of those like 20 times for cucumber. So it must be very productive as far as this hydroponic method is concerned relative to the one produced by soil. So it's I think just by the numbers shown here, I think it's a very good potential to be marketable and to make a profit. So I think Professor Danny Chong, people working on people to get idea to work maybe in Vietnam or in the Philippines. You should keep doing this. Yeah. So it's a high potential to be marketable and to make profit. So that's my comment.
Professor 钟文耀老师 Professor.
Yes.
Yeah, please say something because you are here. Welcome.
Okay. I congratulate both groups, give the very excellent performance and presentation. And especially, I also like to say something to our group. Yeah, even I believe they worked from last night till morning. So this is their, best outcomes. So I congratulate all of them. You did a great job. Okay, good, great. All right, that's it.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.
Professor Xiang, please.
All right. I think it's a very good presentation from both groups, and I asked them several questions, and I think they answer their answer are also very well, and I think so. I think the whole presentation are very good, and I hope this kind of project can be implemented and can be doing this for many times. Okay, thank you. That's my comment.
Okay, good.
We can open your microphone. We give it our judges. Thank you.
Professor Deng Chenzhong, are you there?
Yeah, thank you. Martin, both group had done well. To project very interesting. When you present on the PPT, on the work document, I have you indicate the data have reference. I think it will help you to validate the data. Okay, I only can comment to you. Okay, thank you, On. Thank you.
By the way,
Yeah?
we also have some guests from Vietnam. I'm not sure San Chin still online or not.
Yeah.
Yes, I'm here.
From San
Sure.
Yeah, San Chin.
Yeah, I'm
You
here.
also show
Professor
your
Chung.
video. Yeah.
Yeah, I'm still here.
OK。
嗨，
三清是我们第一届的国际生，他跟这个 Dr. Tan Chuang 是3 batch 的，他们一起来的，同一。
哦，真的。
Yeah, they come
Welcome,
from the same university, right? San Chin, can you show your your screen? Yeah. And Professor Tan also know San Chin's father. Yeah.
So,
Okay.
Okay. Thank you, professors, participants, and guests for all professors' inspiring encouragement and suggestions to Group A and B. Let's give ourselves a big hand for the hardworking, active engagement and online learning in 3 weeks in this pandemic situation. Okay.
Don't forget turn on your microphone, okay?
Yeah.
Clap hands again. Thank you.
Thank you.
Special show is right now, right? Roger.
Okay. Now let's enjoy a video show showing the beauty of Taiwan and CYCU for your memory. Now.
Okay.
Taiwan is making global headlines as it grapples with a surge in local COVID cases.
Fears of a new COVID-19 outbreak in Taiwan have sent its stock market tumbling.
CNN's Will Ripley says Taiwan let down its guard. A Bloomberg report also blames complacency as a cause of its COVID crisis.
Taiwan has seen a steadily rising number of cases over the past week, from single digits a week ago to 333 as of Monday.
Good morning to one and all present here. I'm Vice President Zhong on behalf of Zhongyuan Christian University. I'd like to welcome all of you to participate in the summer program, IIALE. This program is the miniature of a training system to conduct research in CYCU. Due to COVID-19 pandemic, this summer's program is changed to online mode. However, the courses and activities are kept online, and the way to make a friend with your teammate is still possible by your efforts. Hope you enjoy this online summer camp. Since the pandemic is not terminated, we still need to take care of infection. Hope you and your family stay well and healthy.
Okay, thank you. Thank you for your participation to 2021 IIALE. Tomorrow at 11 o'clock a.m., there will be an awarding ceremony waiting for you. Please come back through the connection as instructed online group. I do hope someday in the near future, we can meet together in CYCU or anywhere around the world without barrier. Let's call it today. Now, please stay safe and healthy. Goodbye. So Julia, do you have anything to say?
Yeah, wait for me. Okay. Very thank you, Roger, and thank you, every professor. Actually, we have a activity tomorrow, but just for fun, like this, I share the desktop. I'm showing now? No? Okay. Okay, tomorrow we have a ceremony, but just relax and for fun, okay? So everyone, students, you can join the teams at 11 o'clock. And also we welcome Professor Deng. Are you here, Professor Deng? And Professor Deng, Vietnam. Both
Yes.
are you? Both you are Professor Deng. I always confused. Okay. Let me show you something. Okay. Like this.
I will arrange my time to participate. Thank you.
Oh, yeah. It's just relax, okay? Not a serious. It's an official activity because, as you know, I show you this.
Okay.
Oh, sorry. Maybe I cannot explain like this properly. 邓老师可能帮我一下好不好哈？邓老师在哈。就是说学生们的成绩其实来自非常多元的评量了哈。那包括像这样子的lecture 的表现，就是他的他的 lecture 心得，好，多元的评量里面包括了他的上课的读书心得，还有可以谁帮我一下吗？我们来分享那个 iLearning 的部分 ，iLearning 对 iLearning 的画面，我要再 change 一下吗？来帮我一下。对。已经是了吗？ Sorry, because I always confuse that. So, including this, you can see, yeah. 邓老师好，那我先请您翻译，就是说我们的成绩多元啊，那来自于他的 lecture 心得，还有他在 iLearning 上面的点阅表现哈。老师，你先翻译，谢谢。
Your final score for this special summer program will depend on many factors. The one which you presented, your PPT made, also your review comment on those lectures. Then the last one will be the number of time you spend on reading your iLearning materials. So that will be multiple factors that will determine your final grade for this summer program.
所以可以看到我们的成绩其实是蛮公正的，包括他自己所有的 records 还有 ranking 都是存在的哈。那所以就是
it should be relatively fair to reflect the effort you put in for the summer program.
然后包括这个很重要的就是团队合作的分数哈，我们也都会列入非常成绩比重里面，好，团队合作的分数。
Also your group effort in doing the project will be one of the factors which will be accounted for in the determination of your final grade. And that will be provided by your lab research advisor, the two Professor Jones, one is Bill Jones, one is Danny Jones.
所以在今天这个最后的活动的分数会在下午就把它登录上去哈。那基本上我们就已经差不多有所有的积分了，所以我们明天会开始回到这个最后的一个简单的颁奖活动，然后好，老师。
So the things you are doing today will be recorded this afternoon and into your final grade evaluation. So tomorrow we'll, based on your performance, we'll give a numerous awards to you.
所以最后提醒同学，有没有缴的东西，或是想要再更新或补强的，可以送到我这边来。如果你觉得你要补缴或是更新的话，
最后一个时间是什么时间？
今天5点以前。
Okay, so if you think some the area need to be improved, you can resubmit your revised comment or your revised report. Then the deadline is 5 p.m. today. So then we'll upgrade your grade. Okay.
And 最后一件事就是在请同学们确认完他的个人资讯之后，我们要请他提供给我们他的收件地址。那今天下午我们会进行最后的调查，就是他能够收到这个证书的地址哈。
Okay, each and every one of you shall verify all the data input on your final certificate. Along with that, you should provide your mailing address so we can send those certificate of completion to you. So you will be able to get that without any problem. Be sure to give us your correct update mailing address. That's very important.
OK， 这就是大家今天活动的最后，那我们要掌声来谢谢，最后要谢谢我们的主持人 Roger， 还有我们越南的邓老师，好不好？那我们明天11点一样 Teams 上面见哈，谢谢。老师要帮我翻译，我们谢谢 Roger 跟越南邓老师哈。
Yeah, well, thank Roger and the Professor Deng Chenzhong from Vietnam. We thank you for their special effort to making this final presentation very effective. Thank you.
Yeah. 还有邓老师，还有谢谢我们中原跟越南的学生的表现都非常棒了哈。还有菲律宾对，还有越南对，老师你就直接讲这个。
All students from 3 countries, the Philippines, Vietnam, and Taiwan. So they've been doing superb job. So we want to thank you for all your effort and getting the results and the report in this short summary. Yeah. You should congratulate on your tremendous effort to get this thing done in such a short duration of time. Thank you.
Thank you. So please turn on your camera. We need to say goodbye, and we created a very special history. Right. This is maybe first one and the only one like this summer camp, online. Okay. Please open. Everyone, are you here? And we thank you for the guests come from different country. 谢谢钟老师你的来宾了哈。Okay, everyone is here. Wait a minute. I change my model. Okay. Turn on your camera and turn on your voice. Okay. And we say goodbye, but for 5 seconds. Okay. Just say bye bye and shake your hands. Bye bye. Bye bye. Bye bye. I'm recording, so shake your hands. Bye bye. Thank you. Bye bye. Bye bye. Okay. See you tomorrow. See you tomorrow. Bye bye. Just this. Okay. Bye bye. Bye bye. Bye.
Yeah. Goodbye, Professor Tân, Professor Sung. our professor and our student. Yeah. Thank you. Goodbye. See you.
Bye bye, bye bye. Trời, khỏe quá.
Bye.
Chị em Việt Nam mình xong rồi.
Yeah.
Yeah. Nhớ xem video cho bé
Các bạn ơi, phải hiểu tiếng Việt đó mấy bạn.
nhớ xem video.